Hello my dear listeners, welcome to stackconf. We are going to talk about the path to open source database as a service with Kubernetes today. And I'm not sure what age you are and how long have you been using your open source, but myself, I started using open source quite a little while ago in the late 90s. And in those early days, using an open source software was quite different. It requires a lot more skill, perhaps, at very least a lot more friction. So at that time, I remember we would have to download the sources, in many cases, run some patches to make that compatible with particularly your flavor of operating systems and your compiler, and then compile software before you can use that. And gradually things have been getting better for years, right? We got the target GZ binaries and install script to avoid a lot of that manual compilation and installations. Then we go to Debian and RPM packages, when you can get packages with dependencies. So hopefully we would not only have a program, but also their matching version of the libraries it needs. And then it evolved in the package repositories, and now we have tools like Docker, which can help us, or Snap, which can help us to run the applications even more seamlessly. So what you can see here as a trend is what we are getting things easier and easier to really reduce the barrier of entry. Right now, we can have more and more developers are able to use the open source software. But the fact, I think, comes a very also interesting trend where majority of developers probably would not be able to build from scratch all the tools they really use in their everyday life. I know I'm perhaps one of them. At least I'm not looking forward building some Linux distribution from scratch or browsers and some other complicated stuff. So this is obviously a good thing because it really allows us to use a lot more complicated software, and which is also more valuable, which allows us to do a lot more things faster. And then that also means what a lot more people can be open source developers, even those for whom the open source of late 90s or early years would be too complicated to stomach. Now, I think at face though, we also get the dark side, at least when it comes to the open source angle of things. What we can see is with the next simplification, we can really see the vendor lock-in in the cloud comes in, right? So what you would, if you're really looking at either easiest way to deploy the open source and compatible software, you are likely to do it in the cloud, and then you would be using the proprietary API to do that. Let me provide you example specifically as it comes to the databases. If you're looking at running a database in the cloud, such as MySQL, Postgres, and others, you have essentially two approaches. You can either roll your own using commodity building blocks such as storage, compute, network services, and others, or you can use database as a service functionality, right? Such as Amazon RDS, Google Cloud SQL, and so on and so forth, right? And of course, the using database as a service is something which is much, much easier, but also that introduces a substantial level of lock-in. Database as a service is fantastic. It has a lot of benefits, which is often described as removal of the toil, right? Or repetitive, unneeded, boring work which does not really provide a value to your organization, to your business, right? And with database as a service, those benefits could be ones such as managing your availability without you needing to take care of that, the database patching, right, or patching the operating system to make sure you're not running something with security holes in it, doing backups, some basic performance tuning, and also providing you ability to scale rather easily, right? In many cases with database as a service, you can essentially scale if with a couple of clicks, as long as you have your gold credit card on file. Now, in most of the cloud vendors, right, and I use Amazon here as example, but really other cloud vendors are kind of pursuing a similar strategy, you would often see the two kinds of database as a server. One is your plain good open source product, which essentially is wrapped in the management backend. So for example, Amazon RDS MySQL or Amazon RDS Postgres, they are not really differentiated substantially from those open source versions. The only difference is the management interface, right? Simplicity to do the backups, spin it up, turn it down, right? Setting up replication, and so on and so forth. Then there is also enhanced solution, which is Amazon Aurora in Amazon case, which is really enhanced version of that open source database with additional features, but it is also proprietary, right? So it's better called not open source, but rather open source compatible. Now it's good to point out that both of them really reduce data and so application portability, right? So it is not really trivial to move from Amazon RDS to Google Cloud SQL because your interfaces, the API, if you're programming to them, right, and even some features are going to be different. But it is much harder if you are really using all Amazon Aurora features because it has a lot of additional features or properties such as better performance compared to what you can get with your standard MySQL. So thinking, or I would say our desire in this case would be to get the public cloud database as a service simplicity. So really you can get the database which can run itself, which doesn't require a lot of hard work to do, but really have it as 100% open source solution, right? Could we get something like that? Well, and here I have some bad news for you, and those bad news is what we are not really there yet, right? I'm not aware of the open source solutions when it comes to open source databases, popular open source database at least, which would really give you the same amount of flexibility and convenience. The good news though is over last few years we have this technology which came to a picture. It's called the Kubernetes. What is a Kubernetes on a high level? And of course, you probably know that already, but for those few of you who may not, let me go in a couple of more details. You can think about the Kubernetes as an operating system similar to Linux, but for cluster or set of computer nodes rather than an individual host. And this is very important, right? Because especially when it comes to the databases, because while installing, if you're dealing with a small database and you do not need a high availability, you typically can deploy that on the single host. However, if you need high availability, if you need to scale, then you need to deploy the database on a number of hosts, and in a very particular way, so those hosts really talk to each other and coordinate on the work you do, right? And not just being, separate hosts which do not really know about, right? And this is where the good cluster-focused or data center-focused operating system becomes very important. And Kubernetes is obviously such operating system. Another thing what is important about Kubernetes is it has a lot of momentum right now, and which is very important for success of open source technology. And also it is universally supported by public, private, and hybrid cloud, right? So here are some of examples where you can find Kubernetes. You can see it's found on the top popular major clouds: Amazon, Google, Microsoft Azure. It also is available on the alternative clouds such as Linode, and also if you are want to run solution on premises, there is actually tens of different Kubernetes distributions available for you, where I mentioned here the OpenShift from Red Hat, or now from IBM, as well as a Kubectl container service, which is something from VMware ecosystem. Now, one problem with Kubernetes is what that was initially designed for the applications which are designed as stateless. And the state should have been maintained somewhere outside of Kubernetes itself, right? And here is the tweet, which is actually what's just slightly over a year ago from the Casey Hightower, who is one of the champions of Kubernetes ecosystem, which is talking about the Kubernetes and a caution about running the stateful application in the Kubernetes, right? And database is a quintessential stateful application, because all what database is on a high level is maintaining and changing the shared state of your application, right, or variety of applications, right? So there is such point of view, and indeed what that means is that the stateful applications and databases as a part of that are relatively early, having their relatively early days in Kubernetes ecosystem. Even though over the last few years there have been very important features added to Kubernetes which allows us to build such stateful applications. One of them is a stateful set, right? As the name says, that is a functionality which really allows us to have a stateful objects such as a database which are managed appropriately, right, in the sets which you can think about like as a cluster. The second one is persistent volumes. The volumes which are not which have a life outside of containers, and which you can sort of connect and disconnect separately, right? And then the last one to mention is the operator framework, which really allows to provide the unified interface about how those stateful sets, persistent volumes, and so on and so forth can be orchestrated. Because if you think about the databases, the orchestration is very important. So for example, if you need to upgrade the database, you cannot just deploy the new code, right, on the cluster on all the nodes at the same time. That will most likely cause a downtime or other effects, right? You probably would have some very particular process going on, like you may take the backup or a snapshot of a cluster in case something goes wrong. Then you would gradually replace one node after another in a rolling fashion with a new code, right, to ensure the database stays up while it's being upgraded. And the operator framework is something which allows you to build an application to orchestrate that. Now, the Kubernetes success and Kubernetes fit to run the stateful application can be actually seen through number of public database as a service being built using Kubernetes, right? I know actually more than those, but these are which spoke about using Kubernetes in public. For example, Cockroach DB, InfluxDB Cloud, PlanetScale, all of them have a public database as a service which is built using Kubernetes, which means Kubernetes is actually getting good enough to run database workloads at scale. Okay, well, this is all the generalities. Now, what do we as Percona are doing to advance the state of the databases, of open source databases with Kubernetes? We actually released two Kubernetes operators. One is for Percona XtraDB cluster, which is basically highly available MySQL variant, and then also for Percona server for MongoDB. Right, both of them allows you to really get the open source or source available, right, to be correct in the case of MongoDB database on any Kubernetes solution out there. And with this, I will focus on Percona XtraDB cluster with some more details and with my demo. What is Percona XtraDB cluster? Well, this is a Percona open source product, which is now quite mature. It has been out, I don't know, maybe like for what, 7 years? Well, surely it has been out for longer than Kubernetes itself. It is MySQL compatible, but at the same time, it is offers a cluster with very strong semi-synchronous replication and advanced high availability, right? So it's really fantastic to use in the Kubernetes where for use case when you want to have that high availability. It's open source, and you also can deploy the single node of Percona XtraDB cluster when you essentially skip all that replication and clustering, and then it really behaves as a 100% compatible with MySQL with no differences at all. Now, if you look at the Kubernetes, I think it's worth to note there are a couple of different users of Kubernetes, right, than you would think from shipping the database as a service, right? Or at least we are thinking about those ways. One is the people who have a familiar with Kubernetes or experts with Kubernetes, and they can really use our Kubernetes operators directly, right? And they can get a lot of advanced features in this case. There are also other users who do not mind running Kubernetes on the back end, especially if that's a managed Kubernetes in the public cloud, right? Or maybe Kubernetes in their enterprise, which somebody else manage, as long as they can get a database which is much easier to use. So the first kind of users will run the Kubernetes operators directly, and for second kind of users, we have built the tool which we call Percona Database as a Service CLI, which is an experimental solution for those who want to get the open source database without really having that very deep Kubernetes understanding, right? And how much understanding that really requires, you will probably see from the next few slides when I am going to show you a little demo. So let's walk through the demo. I am going to show you how to run the database as a service on the Google Kubernetes engine, which is very good. I would call that the most featureful Kubernetes implementation among the major clouds. It's available in many locations, and it has a very easy to use command line tool, SDK, which is very convenient to use with Percona Database as a Service CLI. So if you want to use this solution, you would need those three components, right? You will need kubectl. That is the tool which you command line tool which is standard and which you use for interacting with Kubernetes in many cases. You would also need your gcloud SDK, that's your command line tool, and you need the Percona Database as a Service CLI. How do you install those? Installing kubectl is pretty easy. Just use standard commands, right, as I show here. And in all of those installation slides, I am going to show you some of the summary as an image. But really, when you are going to try that yourself, follow the link, which is also included in the slides and which has the current and easy to copy paste instructions. If you look at the installing Google SDK, again, that is the same way, which is a pretty simple. Few standard commands to add repositories and then install packages. I'm following the same pattern, even though some of those packages are also available from Snap or can be built as for sources, right, and so on and so forth. And finally, Percona Database as a Service CLI that is available from Percona repository. Again, I want to point out that this is an experimental tool for now, so it is really evolving very rapidly, and those instructions may change. Okay, after you install all of those tools, right, and assuming you have a Google Cloud account, you will need to connect to that. Google Cloud actually makes it very easily and conveniently. You can use that gcloud auth plugin to connect. That will send you to the browser where you can log in into your Google account, right? And then you can set the project, right, which is how Google talks about different environments that we can be working with. And for each project, it will give you the product code, right? So it would not be just my project, which may be the name. It will give you some funky name, like I got a hide and brace something, right? The next command, what we are doing here is you can actually create the container cluster. And in this case, we are creating the Kubernetes cluster in the US Central Time Zone with given cluster manager. And because that is going to be very small test, we just need the 3 nodes, right? The 3 nodes, which is minimal, needed minimum, right? That is a command number 3. The next one would be to create what's known the cluster binding that essentially gives your user what you're using with kubectl the access what you will be needed to deploy the operator. And then additionally to having a Google Cloud project within each Kubernetes cluster creates, we need to create kind of a project called namespace within that Kubernetes cluster, right? So we are saying what we are creating the namespace, my namespace, and then setting that namespace as default, right? So pretty much few comments how you set it up. And this is something which we would expect the administrator to do, not the end user do it all the time, right? Then if you have after you have set it up, then creating a database as a service will be as simple as this, right? Percona Database as a Service, MySQL, create DB example, where example is your database or like a cluster name, right? When the database is created, by default for security purposes, it's going to be the database which is only visible inside that Kubernetes cluster with no direct IP map to that. And if you want to access that externally, you can use this tool to start kubectl port forward, right? And then you can connect from a local host with your favorite client, with MySQL or wherever it is. Now, if you actually want to expose the database, you can do that as well, right? You would need to, in this case, pass what is seen as a pretty, advanced option where you would specify the ProxySQL service time load balancer, and that will expose essentially resource endpoint of a certain IP, and then you can connect to that directly instead of specifying instead of doing the port mapping or anything like that. Now, the next thing you may want to consider is to how to create database with specific password. By default, we decided to generate random password for you and show it in the output because that is more secure. But in many test and scripting environment, you may want to specify your own password instead, which you can do here. Finally, I should point out what those first few comments, they create the cluster with a 3 nodes. That is a highly available cluster in a Kubernetes, right, which will survive a single node failure and so on and so forth. But that obviously means that you are using the 3 pods for that cluster. If you're just looking for something for development, let's say, hey, I want like a simple scratch database, then you can use this command as specified right there, which will, instead of getting a cluster of 3 nodes, will just deploy 1 node of a database for you, and that's it. Okay. So what you can see in this case is what with Database as a Service CLI, you get database as a service like experience with Kubernetes. Obviously, it's not with fancy GUI yet, but it is much easier, especially for a cluster deployment compared to doing all that stuff manually even on a set of Linux boxes. And we are really working to bring more features and continue to extend the usability, so we will get more of that database as a server flavor experience in the cloud. And I would very much encourage you to give it a try, provide us your feedback, and even participate in development. This is open source projects, and your folks' code is even more welcome than your feedback. With that, I would be happy to take your questions, and thank you.